In the last couple of videos, we looked at the graphing of polynomial and rational functions. In this video, we'll be looking at how to solve polynomial and rational inequalities. So we'll start out with the first example, solving a polynomial inequality. And like the name implies, a polynomial inequality is simply one that contains polynomial terms. So that is, if you take all the terms to one side of the inequality, one side will be a polynomial. In this particular case, we have a third degree polynomial on the left side. Now, in order for the procedure that I'm going to go over to work, you must have one side 0. So in this case, I have x cubed minus 2x squared minus 3x greater than 0. Now, if it happens that you have some terms on the right side and some terms on the left side, then all you have to do is just bring them all to one side. Change the signs when you bring your terms over. Remember, the direction of the inequality does not change. It only changes if you multiply both sides by a negative value. Okay, so once you've made one side 0, then it remains simply to factor, in this case, the left side. So I took out an x, as indicated here in this procedure. I'm left with x squared minus 2x minus 3. The trinomial factors into x minus 3 and x plus 1. The next thing is simply to find the zeros of that factored polynomial. So you can see that from the first factor x, 1, 0 would be 0, because x minus 0 is the factor. The next factor is x minus 3, so 3 would be 0. And the next factor is x plus 1, so negative 1 would be a 0. Then all you have to do is plot these zeros in a number line. So this procedure is very similar to what I did when I showed you how to graph polynomial functions. Basically, I found the zeros of the polynomial and placed them on a number line. Okay, so there you have it. And then I determined the sign of the polynomial on each of the terms. So on the far right of this number line, I have plus infinity. On the far left, I have negative infinity. Okay. So what we do then is determine the sign of this polynomial in the factored form over these intervals. So I want to know, what is the sign of this polynomial to the right of 3? So just pick a number larger than 3. We want to say close to 3. You could pick 3.1, 3.2, whatever. But we'll stay with whole numbers, so I'll pick a 4. And if I put a 4 where the x is on each of these factored forms, now I could do it over here in the original one, but it's easier to determine the sign if I put it into the factored form. So put a 4 there, put a 4 there, a 4 here. Everything is positive. So if I pick a number larger than 4, I get a positive. Now between 0 and 3, if I pick a number between 0 and 3 here, I can pick a 1, I can pick a 2. I'll just go ahead and pick a 1, put a 1 there where the x is, 1, and then 1 minus 3 is a negative, 1 and 1 is a positive. So one factor of the 3 is negative, so that makes the whole thing negative. So this is negative. Between negative 1 and 0, I'd have to pick a fraction, so I'm going to pick negative 1/2. So I put a negative 1/2, this factor then would be negative. Negative 1/2 minus 3, that factor would be negative, and negative 1/2 and 1 would be a positive. So the two negatives in the first two factors cancel out and become positive. So in here it's positive. Now to the left of negative 1, I'm going to pick negative 2. So I'll put a negative 2 there, negative 2 where the x is, negative 2 here. And you can see all three factors are negative. It's an odd number, so the product of those is going to be negative. Okay, so very similar to what I did in the graphing of polynomials. So now what does the inequality read here? It means it reads greater than 0. So the answer is right here in the number line. So greater than 0 implies a positive. So the solution then lies between negative 1 and 0, or to the right of 3. So that would mean then that if I use the x to denote the solution, then x then would have to be greater than -1 but less than 0, or x would be greater than 3. Okay, so this is one way to write your solution. Okay, so again, x greater than -1 but less than 0 puts it into this interval here, and x greater than 3 puts it over here. So it's either all numbers in here or numbers over here. Now, in the course that I taught, we usually gave the solution in interval notation. So this same solution can also be written this way: -1 in parentheses, -1 comma 0, and then instead of the or we use the union 3 to infinity. Okay, so this is the interval notation for the same answer that I have over here. Now, the only difference is if this had been less than 0 here, then the only difference then you would look at the intervals that have the negative sign, okay, and write the solution from that. Now, if this were greater than or equal, then we want the values of x and make this side greater than or equal to 0. So obviously the value of the zeros is what makes it 0. So in that case we would put brackets. So if this had an equals under this inequality, I would have a brackets right here at the -1 and a bracket right here at the 3. Okay, instead of the parentheses. The parentheses simply means everything between -1 and 0 here, and then here 3 to infinity. You never put a bracket on the infinity or the negative infinity. Okay, that's the solution for that one. Okay. If you have a rational inequality, that's simply an inequality that has one or more rational expressions. So again, you want one side to be 0. So it could be that you have a rational expression on the left side and a rational expression on the a rational expression on the left side and a rational expression on the right side. So what you want to do is you want to bring the expression on the right side, say, to the left side, find your lowest common denominator, and combine. So you want it to come out with one side 0, okay, like the way this one is, and then the other side you want it as a single expression. Okay, you want a single expression on the left side. And then if you can factor the numerator, that's convenient because that's going to allow you to find the numbers we need. The same thing with the denominator. Okay, so your final setup should look like this. Then on the number line, you're simply going to plot the zeros of the numerator, which in this case are 3 and -2. Those are the numbers that make the numerator 0. And the zeros of the denominator, which is just 1 in this case, 1. 1 makes the denominator 0. Okay, so I have them plotted right here, -2, 1, and 3. So just like in the problems on graphing rational polynomials, the same thing here. I'm going to determine the sign of this expression on each of these intervals. Again, infinity is over here on the right, negative infinity is over here. So again, if I pick a number larger than 3, say 4, put it here where the x is. The two factors in the numerator will be positive. The factor in the denominator will be positive. So everything comes out positive. Now between 1 and 3, I'm going to pick a 2. So put a 2 right here. 2 minus 3 is negative. 2 and 2 is positive. 2 minus 1 is positive. All I care is about the sign, okay? Since one of the factors is negative, then of course this is going to come out negative. Between -2 and 1, I'm going to pick 0. Okay, you can pick anything between -2 and 1, fractions or whatever. Always convenient to pick whole numbers or integers. 0 is a convenient value, so if I put in a 0 where the x is, I get a -3 here, a 2 here, and a -1 here. The negatives cancel out, so this comes out positive. Okay. To the left of -2, I'm going to pick -3. So pick -3, so put a -3 here, a -3 here, a -3 here. Okay, so negative 3 here and a negative 3 here, those two factors will be negative when I combine, and then when I multiply two negatives I get a positive. But the bottom is going to be negative, so a negative into a positive is a negative, so in here it's negative. Again, your solution is on the number line. You simply read the solution from that. So this reads less than or equal to 0. Less than means negative. So you simply look at the intervals that have the negative. Had this been a greater than here, then you look at this, the interval with the plus sign, and write the solution from that. So in this case, this would tell me that x then has to be less than negative 2, because it's to the left of that. Okay, so what do we want? We want to make this expression less than 0 or equal. Okay, well, the negative 2 makes the numerator 0, so that will make the expression equal to 0, so I need an equals under this one. Okay, and then or x could be between 1 and 3. Okay, so I'll start off by saying, okay, between 1 and 3, that's the negative interval. X then would have to be greater than, okay, let me fix this here. So x would have to be greater than 1 and less than 3. Okay, now we have to decide if we put equals under the inequality here. Okay, so x has to be greater than 1. Okay, now here 1 makes the denominator 0, so remember division by 0 is not defined, so I don't want an equals under this one here. Now x less than 3, and 3 makes the numerator 0. Okay, you can have a 0 in the numerator but not the denominator. Okay, so that satisfies the solution, so I have equals here. So you have to be careful when you have an inequality, especially a rational inequality, where you have an equals, okay? Because you don't want to put an equal for a value that makes the denominator 0. Now if it's a polynomial, there's nothing in the denominator, it's going to be 0. So there you would have brackets on all the values, except on the ones that have the negative infinity or the plus infinity. Okay, so this is your solution here. Okay, now if I use the interval notation, so let me lower this here, this is what it would look like. Okay, so negative infinity, negative 2, that's saying this right here, x less than or equal to negative 2, or instead of the or here, it's the union. So again, parenthesis here means that the 1 is not included, brackets here means that the 3 is included. Okay, so x has to be less than or equal to negative 2, and x has to be greater than 1 but less than or equal to 3. That's your solution. Okay, that concludes this video. We'll continue with other videos in college algebra. Again, if these are helping you, please subscribe. If you have any suggestions, please post them, and I will consider them. Okay, so we'll see you in the next video.